Hello. Okay. Hello, everybody. Hello, hello. So, what are we doing today? I'm thinking those any10 files that I excluded yesterday might be useful. See what Hexops thinks about this. Did they keep them around? Yep. And well, no, they list them here. Uh-oh. And then they don't put them anywhere. So this is telling me that there are 3 entries and they're all overlapping. Okay. Okay, yeah, they do may and presume for everything every time you have it. So either it is, oh, I see, either it is ARM or it is Arch64. Okay, the any10 stuff, I have no idea. Okay, our package is now more complete. Let's go. Okay. What was the first programming language you tried? Hmm, I think technically C++, but the first language I tried like seriously was PHP a long time ago. Okay, so let's get started. What are we doing? Well, today we are packaging our noise because we need to well, we need to build it if we want to use it, and then we want to integrate it with Awebo. Actually, before I start packaging it, I'm gonna take a look at the header files because I want to see what the interface is, like how you use it, just to make sure that it doesn't have like some weirdo restrictions that make it impossible for our use case, which I don't think is gonna be the case, but you never know. Actually, I'm gonna tell people also. Okay. Do. Let's take a look at the interface. So, what does this guy want for us to be able to use it? Uh, DLL export. Okay. Return the size of the noise state. Return the number of samples. So the number of samples processed by our noise process frame at a time. Initializes a pre-allocated denoise state. If the model is null, the default model is used. See our noise create and our noise model from file. But I don't want I don't want a model from file. Oh well. Allocated initialize a denoise state. Okay, there we go. Denoise a frame of samples. In and out must be at least our noise get frame size large. What is this number going to be though? Well, I mean, I think in our case we have a ton of flexibility. I think we are going to be fine. Model from buffer. Probably that's what we're gonna do. The model from a file? No. From a file name? No. Create custom model. What? That's it. Okay, this interface is very simple. Wait, what are the restrictions? Okay. What are the restrictions? It operates on raw 16-bit machine endian mono PCM files sampled at 48k hertz. Well, fuck. Okay, so here's annoyance number one. We're doing float 32. So we're gonna need to convert float 32 to 16-bit samples. 16-bit. So 2 bytes. Well, so that's a thing that we're gonna have to do. And then the output is also 16-bit raw PCM files, of course. Not again. The input and output are in raw format, not WAV. Wow. Wave, not wave. Um, I don't get what the difference is. Also, are these 16 bits? I guess you assume that they are signed. I guess they probably told us in the signature of the include file. In the signature here. Okay, no. Wait a second. You son of a bitch. Why is this float in, float out? Why is this float in, float out? Last I checked. Last I checked. Float is not 16-bit. I guess it's the README that it's a bit obsolete. Hopefully. There's a doc section. There's an example section. Hmm. There's download model. When is the latest model? Oh, there's one. 2025. Oh, this one seems delicious. 56 megabytes. This model data thingy seems delicious. 37. 8B37. Is that what they're using here in head? Yeah. Okay. I think we're going with I think we're going with master branch for this one. Sorry, main branch. We like head commit essentially. Okay, this all seems. Wait, we is it float or is it integer? I would assume. I think they moved to float. I would assume they moved to floats. Well, okay. Let's see what is the function that we're looking implementation for. Process frame. Show me the implementation. It doesn't know where to find implementation. Okay, it's okay, GitHub. You're a little bit slow. It's fine. Paste. No, it's not part of the same thing, you silly goose. There we go. The noise, let's see, I had it. Not even that hard. Yeah, well, I mean, that sounds to me float in, float out. I mean, we already kind of could tell that with a reasonable amount of confidence from the header file signature, but good to know. Good to know. Float in, float out. So this is good because that means that it's one less annoying step for us. Okay. So let's begin a package. So MK there. I'm gonna go to zip our noise. No, I don't need that. That's only if I need to clone the original, which I don't care. MK there our noise. Git init. Do I make it on GitHub? Do I put it on GitHub? Do I put it on Codeberg? Yeah, I'm gonna put it on GitHub. That's where Opus is already. So might as well start by creating the repository there. On our code base, the repository. Oh, actually, right. You do it from here. Wait, what? Huh? 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 Can you imagine? There's already one. The problem is that they're not doing the pristine tarball approach. And what? Where's the where are the optimizations? There's a demo. Awesome. Where are the optimizations though? I think we're gonna start this from scratch again. I think we're gonna add a main branch, set that the default, and this stuff is old. Yeah. Okay. Huh. Is it in settings that we do this? branches. Add branch rule set. No, I guess we do it from here. View all branches. New branch. Main. Can you not have can I not start from scratch? I'm very close to obliterating this repository and recreating it from scratch. Okay, how do you create? Okay, let's do this. First, we clone this. Um, okay, how do you create an empty branch? Git create empty branch. Check out orphan branch name. Okay. Let's copy over the git ignore. Let's copy over the readme. Zig init -m. Zig will for if are noise. I don't know. Let's leave it at that for now. Zone file. Name or noise, blah, 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 blah. Fingerprint. That is fine. Next, we need to add dependencies. So zig fetch, save. So zig fetch, save. Zip opus, but it's actually not zip opus. It's R noise. And watch this trick. I can click and rename stuff. I'm actually thinking of calling this upstream. I started calling these things more recently upstream, and I think it's better just upstream. Okay. Delightful empty build script. Okay, what are we gonna make? We're gonna make a module. B dot add module. Name is gonna be R noise. Options is gonna be target equals target. Optimize equals optimize. What are those? Const target equals b dot standard one. Standard optimize options. No, that's optimize. Oh man. Standard target options. Ta-da. Yeah, we're doing pristine tarball. Honestly, pristine tarball is so superior to alternatives. I'm sorry. I get that you can delete useless files with the other approach, but depending on the original project in its entirety, it's just so good for everybody. So that you don't have to verify shit. It's just the original thing, and then they can copy paste it over, and then they can literally replace upstream with B, and done. That's it, and it works. Like literally just changing upstream with B. Um, so mod is b.add module, our noise. Then we need to add C files. We need to learn which C files to add. Also, this bad boy has thing that it depends on, like a download that it depends on. So we need also to account for that. Give me the zip RN noise repo. So this is the model version. So we're gonna need a bunch of stuff. Okay, we're gonna need I'm gonna start from their thing here. So it's RN noise data. So copy. Oh man, so now it's gonna be a Frankenstein. So Zig fetch, save, model, and it's gonna be this plus noise data dash noise data dash plus their thing dot targz. Copy dot tar dot gz. Okay, there we go. Now we have this as a dependency. Perfect. Paths. What do we have in paths? We have build.zig, build zig.zon. That's it. These are the important files in our case. Why is the fingerprint down here? Why is dependencies up there? You come down, sir. Okay. Build a zig. Okay, now we need to learn which C files to add. So let's get inspired by. Also, we need to learn about their options. So we could take a look at their config file, their configure. But you know what? I started actually liking. Oh, this one is actually very simple. This one seems very simple. We might as well just read it here. But one thing that I started liking is you just run the configure script, and by running the configure script, you're um like you're generating a example header file that has all that you want in it. Pedantic, W all, W extra, no sign compare, no parentheses, no long long. Do any of these flags matter for the generated stuff? You know what? Because I'm thinking also of Ziv Opus. Sorry, I'm briefly gonna go in there. What do they have in their config stuff? Where is it? Which horrible flags do they put in there? Let's find W all. W extra, cast align, nested externs, shadow, strict prototypes. It's just for warnings, right? Yeah. So these are the stuff that we are not going to touch ourselves directly. Okay, so that's it. I think we're good in that case, in that sense. Okay. Define unquoted Win32 in NT0x501. We need at least Windows XP for get other info, read other info. I think we're gonna be good. So um so we need to take a look at their config file and we need to set the flags. Um yeah, you know what? I really like being able to just look at the generated file. So look at what we can do now that we have Zig package. You go into Zig package, you have to figure out which one of these guys is which, although you know from the zone file, zip our noise ends with VF. Unfortunately, normally this would be more telling. The problem is that since they are not proper Zig packages, they have N and V, um, where you would normally have something that tells you what this thing is. It's fine. So in any case, we enter in here and then just fuck it. Let's run autogen, um, which will download crap. Now, there's one thing to keep in mind. If you run stuff in here, you are modifying the state of this directory. So um, you have to be careful. Essentially, you have to delete the directory. Uh, you have to delete this directory once and let Zig recreate it once you want to be sure that you're not relying on side effects. Okay, what do we have in here? Fine tuning binders, this is binder, blah 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 blah, whatever. Disable feature, disable large file. Oh, there we go. Optional features. Do not include feature. Include feature. Disable large file. Omit support for large files. Enable dependency tracking. Do not reject slow dependency extractors. Speeds up one-time build. Enable silent rules. Less verbose build output. No. Maintainer mode. Disable make rules and dependencies is not useful to the casual installer. Enable shared. Enable peak. Enable fast install. Enable AIX, SO name AIX as before, both. Shared library versioning. Oh. Lib to lock. Avoid locking. Might break parallel builds. Enable assertions. Disable examples. Enable DNN debug float. Use floating point DNN competition everywhere. Enable RCD. Okay, so these are the ones. Support timestamps after 2038. What? What is going on here? What are these options? Okay, so here's what we do. We just run configure, and then we do config.h. Take a look at configure.h, and then we basically replicate these in our build script, and we use our judgment to decide what values these things should have. So, for example, disable debug float. We'll probably want to have it on. So, const config equals b dot add config header. I don't remember what the options are, but values is the thing that we were doing yesterday. What options can you pass in? Style. Oh, style is autoconf undef. Autoconf at. Wait, you can provide one of these guys? Instead of starting with an input file, start with nothing. And this defaults to, I guess, blank. Wait, okay, so you can pass in. So wait, you can pass in a one of these guys, I guess, and it will, and I guess Zig will basically force you to provide all of these, and that's a cool feature, which I'm not going to use. We're going our own way, but cool, good to know. Okay, so um, RTCD from ASM only for now. Oh, the h.in file, you mean? Yeah, but we don't have that. Are you sure that this one wouldn't do? We don't have a config.in though, right? I might be wrong actually. Maybe we do have it, but I don't think we do. This is another thing. There's this. There's this. There's no config.h.in. Is anyway mentions in here? Nope. Is it the package tarball? Not the repo clone. Really? Apple, why do you think I want to look at directories that way? Holy shit. Oh yeah, it is here. I don't know. Give me fucking text edit. Yeah. Well, you know what? Maybe this is good to have around. How do they generate this? AutoConf creates it. So you're saying that now I have one. Oh, so you're saying that by running it, I have one as well. Oh yeah, you're right. I have one. Okay, I guess we can switch from one to the other. Yeah, cool. RTCD from ASM only for now. I don't know. Okay, disable debug float. True. Next. Define one if you have DLFCN. I think we have all these things. Define one if you have Minix. We do not have Minix. Okay, so I'm gonna move these up. I'm gonna grab all of these. We're gonna do all no, we're gonna do all of them at once. Why am I doing this? Space yank, paste. There we go. Uh, okay, have Minix. I'm gonna say no. Have Minix config H. Then define to the subdirectory where libtool stores uninstall libraries. We don't care. Enable assertions in code. This one we do care. OP enable assertions. You can omit it if you don't want to have the option. But that is fine. By setting it to null, it's still going to be undefined. And I like to leave it here because, eventually, if the people that work on RN noise decide that they want to upstream this, they will have it here. It's going to be unwired, but they'll have an opportunity to do something about it. So enable assertions, default false, or else, actually no, or else, that's it. Then package bug report, package name, package string, URL version, RN noise build we want to set, yes. STDC header. Define one if all of the 89 standard headers exist. Yes. I think it's STD. Oops. I think it's STDC, right? Oh, without have. STDC headers. Support attribute visibility default. Enable this if the compiler supports this shit. It seems that we do. Oops. Support flag visibility. Seems that probably we do. All source. Enable extensions on AIX, Interix, ZOS. I don't know. Enable general extensions on macOS. Enable general extensions on Solaris. Enable general extensions on systems that have them. I'm not sure I understand what this stuff is. Enable X/open compliant socket functions that do not require linking with LXNet on HPUX 11.11. Also, why are these defined with this style? I identify the host operating system as Minix. And then this is commented out. So we are recognized not as Minix. NetBSD, OpenBSD for POSIX compatible behavior. Define two for POSIX compatible behavior. Enable POSIX compatible threads on Solaris. Enable specified by ISO ISCTS. What? What are these things? Number of bits in a file offset. On hosts where this is settable. Define one on platforms where this makes of T a 64-bit type. Number of bits in time T on hosts where this is settable. Windows XP. Define one on all platforms where this makes time T a 64-bit type. Now, here's the thing that I find mildly concerning. Why does this library concern itself with time? Why does it care about time? Why does it care about time? I don't think this library has a reason to care about time. I don't understand why it does. Like, also the stuff about files is silly, but that is because it gives you the ability to load um models from files. I guess that's fine. But the time stuff, why does it care about time? Where is time t usage in this library? Now watch, yeah, watch GitHub search bungle this horribly. GitHub. You know what? We should stop calling it GitHub. We should start calling it Microsoft GitHub. Because it puts things into perspective. Microsoft GitHub. Of course, search doesn't work well on Microsoft GitHub. So wait, the only places where we mention time t is in the config file and in our cache. Why? Where's the ignore? No ignore. Just to be safe. There is no usage of time t anywhere. Why does it care? I think this is vestigial stuff. Also, I don't see why you should care about this, really. But in any case. So, okay, so then the question is, yeah, what am I gonna do about these other settings? I don't know. I don't think we have to worry. I don't think we have to care. I think we want to set this on. I think we want CPU info by ASM set to true. And then we'll see if this can actually work for real or not. Okay, so we had the config header to our module. So far so good. Now we need to figure out the C files. So what C files comprise this library? You usually see that in the make file. So you see that there's a bunch of header files in there. That's easy. Oh, there's some that are architecture specific. So there's an x86. Although it doesn't really matter much in terms of header files. So that's gonna be easy. So mod dot add include path, and this is gonna be upstream. Oh, also wait, we need to grab the upstream dependency, of course. Of course. Const upstream equals b dot dependency name upstream args none. And then we also need model. Okay, so include path is gonna be upstream dot b upstream dot path, and it's gonna be source upstream. Okay, we're gonna add source. Then there's x86, which we only do if x86. So let's do this const CPU features equals. Actually, I'm gonna make a type for this. You can even do it like this. x86. Cool. I mean, we can um no, we don't do this because this is silly. But we're gonna need CPU features though. We're gonna need it in a moment. So we can do this. If target dot resolved, sorry, result. What is it? Result. Yeah. CPU architecture is x86. Then include path source slash x86. There we go. Now we're happy. The fact that these other ones are not namespace makes me think that you can have them all the time. Um, then let's see, our noise sources. Yoink, copy. Why is there an arrow for the first one? There we go. So we can do mod dot. Actually, I'm gonna do it below. Add C source files. Root is gonna be upstream dot path source. Files is gonna be uh, it's gonna be our noise sources. Then flags, I don't know yet. Language we can leave automatic detection. So now we need to do these guys. Oh, RTCD is an x86 thing. Interesting. So, okay. So that means that I guess we want this to be if target dot result dot CPU dot arch dot is x86 true else null. Okay, then const there we go. And this one is going to be AVX2. Then we need RTCD. Okay, let's see if we can do this the way I wanted to do it originally. So can we do it this plus plus if um yeah. So this is why I want to do CPU features. SSC for one, we do our noise sources. Oh, but we cannot do plus plus with slices, can we? Can you do plus plus with slices? Maybe yes. No, no, you can't. Never mind. I'm dreaming of a thing that is impossible. Let's call these C flags. Hello, Queen. Actually, we can even do it like this, right? We keep it on a single line. Way too long. Never mind. And then we do if CPU features SSC for underscore one, then this, but with our noise sources SSC for one, AVX2, AVX2. There we go. And then there's the RTCD. Um, let's do. You want to do it this way? Yes, we can do it this way. Um, okay, there we go. The only thing we need to fix is the CPU feature stuff. So SSC for one and AVX2. Oh, you know what? Now I remember. I remember why I did care about this in Opus, and actually here it's overkill. So in Opus, I needed to pass around these CPU features in a bunch of sub compilations. And so grouping them into a struct was beneficial, but here not anymore. So we don't need to group them under CPU features. We can just have a couple of variables for it, and it's going to be good enough. So SSC for one and AVX2. So const SSC for one is target result CPU architecture is x86 and std dot target dot x86 dot uh, feature set has target dot result dot result dot cpu dot features SSC for one. AX2. There we go. Um, I think this is it. I think this is it. We're missing model stuff though. Let's see. If enable this. Then you have to add this, this, and this. Okay. Lib R noise. Oh wait, this is adding them unconditionally. So I guess we'll see what happens. But that makes sense that if you have runtime detection, then you want all of them. Anyway, um, yeah, you know what? I'm being a silly goose. When you have RTCD, you actually want to keep these guys uh always on. Okay, so let's do it like this: x86 RTCD. Actually, just RTCD. Actually no, x86 RTCD. I like this. I'm gonna rename this thing down here to sources. RTCD sources. RTCD sources. And then RTCD is b dot. It's this is it's a b dot option. It's a boolean. And if you pass it in, and also what do we do if it's null? If it's null, I guess we leave it null. No, I think we want it like this, or else false. Then we want an if in here that says, okay, well, if you do set it though, um, assert the target.result.cpu.arch.is. Either we do is x86 or we ignore the setting. What do we do? It's less explicit, but I think it's fine. Okay, I think it's fine. I was deciding if I wanted to complain if you try to set this on and targeting non x86, but I decided instead to do this. We basically toggle it off if it's not x86. So this has to be, so that means that SSC for one is either because the CPU supports it or because RTCD is on. So it's x86 RTCD or this and this. Also down here, x86 RTCD or this and this. Okay, perfect. And so this way, either you don't do RTCD, and we know at compile time that you're targeting a CPU that has these features, and we are going to include these files. Otherwise, if you do RTCD, we have to include all of them. Even if you're targeting a CPU that we don't think has these features. I need to apply this fix also to Opus, I think, because Opus has the same system, and yeah, we're not doing it justice. Okay, so this is all well and good. So this part has been fixed. Where's the model stuff though? So our noise sources, lib add. What's lib add? Lib m? Lib m. Is it defined like below? Extra dist. Then there's all the various steps. If RNN enable x86 RTCD, was that the name of the option? So wait, this is a setting that config.h doesn't set. Oh, snap. I think the config stuff is kind of out of sync. Yeah, also, you know what? I don't know what this should be set to. Now I don't know how the ASM feature detection works, but this is x86 RTCD. That's for sure. And actually, it needs to be like this: if x86 RTCD, true, else null. Because I don't think you have to set it to 0; you just leave it unset. So rnoise sources, lib rnoise la sources, lib add deps libs, lib am, ld flags, no undefined, version info, programs. We don't care about programs. Enable examples. We don't care. Oh, OP stands for opus. That is funny. OP, where is it? Like OP enable assertions should actually be renamed to RNN enable assertions, but they forgot. uh, yeah, features training. We don't care right now. Debug ggdb OP enable assertions. Oxygen and if configure AC. Okay, this hook phony. Dot C equals dot LO. Yeah, I don't think that pertains us. We are missing some stuff in this whole thing. What we're missing is the files that we got by downloading the tarball. Where are these guys being mentioned? Oh, you know what? I think it might be that we are supposed to um, kind of like embed them manually or something. I don't know. Let's take a look at the files. For example, do we have cell LPC? Let's take a look at the files that we have. Yeah, so we have these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 files. Okay, that sounds about right. x86. Also, the neon stuff, for example. Include ARM neon. Okay. Yeah, where's the model though? Okay, so in here, I downloaded the model and I don't know where it went. Um, mm, mm, mm. Did it go into models? 12 and 15? 10, 10 GA, 10 GB. Um, our noise data. Okay, let's do this. Let's download this stuff separately and let's see what's in there. Like I don't know this file where like where it got extracted, so that's the problem. It's an unsupported format. It is not an unsupported format. Stop being a pussy. Come on. Contains models and source. Source contains rnoisedata.h, rnoisedata.c, rnoisedata.little h, and little c. Okay, so this guy turns out, I guess little is meant to be a like a smaller version of it. I guess this one is the, I don't know what's the weight of these files. They're all, I don't know which one. Do you need both? Is it one good enough? Hard to say. rnoisedata.h. Okay. Little.h. Data.c. Use weights file. Oh, wait a second. Is this a big boy file? Are these big boy files? Holy shit, they are big boy files. Okay, I get it. So these are the ones that you get. You have to decide: do you want data or do you want data little, essentially, or I guess both, or well, or neither. Um, I guess we're getting data. We want the good one, right? I guess this could be made an option. So first of all, our noise data is a lie. It does not come from. Also, is the where's the little stuff being mentioned in the make file? The answer is nowhere. You know what? Let's. Why do I keep going to GitHub? This is such a bad habit. Here's what we're gonna do. RG little. Whoops. The format is blah, blah, blah. We provide a little model we have as an alternative to use the smaller model. Rename little to data, right? To build both the regular and little binary weights and load any of them at runtime since the little model has the same size as the regular one. Size in terms of like configuration, okay. Um, I don't know. Let's make this a build flag. Okay, so we have the little model. So now in here we want to do this. We want to do um I guess we do it at the end. Mod dot add header include path. This is going to be model.path. Then mod.add C files, C source files. Actually, you know what? I'm going to copy these. C source files. This is going to be model dot path period. In files is going to be if little model model little dot c else model dot c. Um, Now there's the header file problem, but it seems that maybe it's a problem, maybe not. I don't know. I guess we can run this and see if we build. So I'm going to exit here. I'm going to Zig package. Oh, I'm also a dummy. I had it downloaded there. I should have gone into the other directory. I would have seen it. Yeah, so here we only want source. Actually, did I go into source correctly? I don't think I did. This is include path source. Model path source, and here model path source. Yeah. And its status. And we are deleting this guy because we did side effects to it. Can we Zig build? The 3 arguments found 2. You're right. That's a Boolean. Right. Build doesn't do much. Now here's the thing. We want to also add a. So this is all well and good, and we're like 90% done. Um, the the situation is this: a module will contain all the C files, but it will not contain the header files that we're supposed to install. For that, I think the correct practice would be to add a translate C step, which might actually do that. I've never done it, so I might learn. But in any case, let's say that we want to also make a static library or a dynamic library. Also, like allow these to also create artifacts so that C can use. So definitely want to do that. So let's do this. Uh, um, lib equals b dot add library. Let's set some options. Linkage equals it's either dynamic or static. So this one we let the user choose, I guess. So we do we do b dot option. Maybe we should have two. You know what? Let's create two. Const dynlib is b dot add lib library to do. Linkage equals dot dynamic. Root module equals mod. That's actually it. Like, what else do we wanna put in here? Oh, name. Maybe we should put a name, shouldn't we? Our noise. Use LLD, use this, use that. Okay, none of the other options interest us. Dynlib dot install header. Source is going to be upstream dot path include. Actually, is it header or header something else? Let me. Is it going to install like a single path or what? Let's see. Dynlib dot install headers directory. I think we want the directory. What's in there? I think we want all of include. I mean, it's only one file for now, but you know, if they decide to add more in the future, to destination relative path, nothing. Options. What are those options? I don't know. Exclude extensions, include extensions. No, like this. Install headers directory, and then we do the same with the other one. So let's do here just lib static. Okay, and then we do b dot install artifact lib and b dot install artifact lib. There we go. And now we create also normal artifacts, which now will make the Zig build do stuff for real. Now let's see how our configuration goes. Not great. Something source slash model.c file not found. Oh, I messed up that name. What's the actual name? Rn noise data. And Rn noise data little. Why did I brain fart it so hard? Okay, let me double check. Rn noise data little. Okay. Okay, got 4 errors. Let's see. rnoise.h file not found. So dnoise.h wants rnoise.h, which you cannot find. Interesting. They want the main header file. So add include path source, add include path include. Actually, maybe include should go first. Okay, this is luxury. Usually you get more errors than this. But, you know, there might be more hiding behind. Let's see. There we go. And in Zigout, we have rnoise.h, static library, dynamic library. Let's get freaky now. So Zig build dash d target equals x86 for Linux. Let's go. Will this work? 12 errors. What are we missing? String.h, file not found. Right. There's an important thing. Our module needs to link to libc. This was not a problem on macOS because on macOS you implicitly link libc. But on other platforms, obviously you have to do it. Otherwise, you're not going to have a libc. Success. Let's see, x86 for Windows. Will it blend? So we're not really testing that it works for real, unfortunately, but we're testing that the build works out, and it's good. The fact that it works out, it's good. Let's see. Now we have the DLL. Oh, interesting. The DLL goes into bin, but the dylib and the SO go into lib. What? I wonder if this is Zig, the build system not doing something that it should do, or if it's just live in the Microsoft universe. Who knows? Okay, let's do the last thing, which might or might not work out. We'll see. I've never done it before. So after we set up the entire mod build, actually maybe we can do it. Yeah, no. After the mod build here, before libraries, we're gonna do this. Can we do mod dot add tran? No, it's I don't know. B dot add translate C. Okay, how does it work? How does a add translate C work? Oh, you'll have to explain that to me. Root source file. Target optimize. So target optimize, I get. Oh, wait, there's also use Clang? Oh, we can still use Clang. Oh, wait a second. Oh, I didn't know we have this. So I'm assuming that the root source file is the header file that you want to translate. So let's see. Root source file equals upstream dot path includes slash rnoise dot h. Target is going to be target. Optimize is going to be optimize. Link libc is going to be true. Use Clang is going to be true for now. Uh, so this creates a module. Not well. This creates a translate C, not a module. And then we do mod dot add translate C. C mod dot what? C macros includers link libc optimize out base name output file step target use Clang add after include path add check file add config header. Okay, these are all the normal things that you can do. Wait a second. No, these are not the normal things that you can do because a translate C is something different, right? The dedicated thing. It looks a lot like a module. Get output. Creates a module. Oh, there we go. Creates a module from the translated source and adds it to the package module set, making it available to other packages which depend on this one. Create module can be used instead to create a private module. That's what we want. So we want to do add module. Almost like this, I think. B.add translate C dot add module. I want to call it. Actually, what do we call it? So RN noise is going to be the main module that contains all the implementations. What do we call this one? Headers. This is the first time that I do this, and I don't know what's a good way of naming this stuff. So the implementation is called our noise. No, I think that what we want to do is not expose these as a completely separate thing. Although I think it should be like this. Okay, let's do it here. Does add module return a module? Yes, it does. Okay, so no, we want to do it like this. Add translate C. Actually, no, like this. Headers. And then we add it to the module. So we do mod.add module, add import. Oh, come on, give me a suggestion so I can see the signature. Name headers. No, adding it as submodule does nothing because this module is not going to use this. But okay, I think we can do it like this then. Headers is the translate C. We do add module on it and create headers. And then instead of giving it a submodule to this guy, which it really doesn't care, we can do this. We can do dot root source file equals headers. Maybe output file. Get output. Let's see, what's get output? A lazy path, a file. Yeah. Okay, so let's see if I understood this correctly. So this makes the translated header file available as a separate module that you can. So by doing this, a user could, in theory, just get the translated headers without our implementation. Which, for example, this would work well if you want translated C headers plus maybe the dynamic library. I don't know. Then this gives you a module that contains the implementation and as at the root the same definitions. I don't know. Let's see where we go with this. Does it build? Do we build? This is probably not going to change much because we are not really stressing much the mod side of it. Oh, although okay, it works. Although yeah, we did change a little bit the mod. Okay, I don't know if this is the recommended way of doing it. Really, first time that I'm doing this. But I think we have a working build. Now the next step is to test it out with Awebo and see how it goes. So give me a second. I'm gonna take a very quick break and we're gonna wire this to Awebo and see if it blends. Essentially, I'll be right back. But one thing that I want to check though is we are unconditionally including the neon stuff. Will we get optimized behavior? Maybe we should look at the C source code to see. Oh no, but we saw that how it does it. It just looks at the ARM definitions. I don't know. I'll be right back. Hello. Hello, hello. Okay. So T is up. Um, mm, mm, mm. The CPU info by ASM. I don't know what that is. I don't know when you can turn it on. It was off for us, so I'm gonna leave it uncommented for now. Actually, I'm gonna also uh change this. We just don't know. Okay. Um. So our build script seems good. Let's try it out. So we go in. Um. Hmm. How are we gonna do this? Well, we go into our actually nothing. We go into Awebo. We do Zig fetch save our noise actually without even name, I guess. But so I don't think we're gonna be able to fetch. No, we will be able to fetch the other project. It's just that it's gonna be all kinds of fucked up. Okay, so save git plus all your code base our noise. Never mind. It's even worse. Okay, so this is super bad. This is not gonna let us do this. So I'm gonna add a dependency manually for now. So we're gonna do into our zone file. Yes, next to Opus. Oh, there you go. As simple as that. Then we go into our build script and we start using it. So our noise, well, we're gonna start need to configure it next to Opus. Any other feature that we care about? Mm, 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 mm. Oh, the RTCD stuff. I think we want the RTCD stuff on. Nice that I didn't complain because so now we can use it without worrying too much. Everything else is in there. I just enable assertions essentially. Okay, so true. So now we have our noise, and then we can just add it as a dependency. Okay, this should be a better integration than what we had before. Mm, let's see if it works. Also, the fact that this error is staying for so long is actually promising because it means that we are running the build and it's taking a while for the build to complete because it's actually succeeding. I think. No, never mind. It's just because uh, I didn't do, I didn't rename that variable. Never mind. Okay. Now we should be good. So now let's try to do Zig build GUI and see what happens. Invalid option D, assertions. What did I call it? Oh, enable assertions. Assertions. What did I call it in the other one? Just assertions. Yeah. Okay. Okay, so we compiled the error noise stuff. We saw it here. Linking succeeded. We got no complaints, so we should be in business now. Okay, so now if I go, I restarted the editor because we changed the build script, so I wanted the ZLS to see the updated build script. So now in theory, I can go in, let's say, network, and in media send, in media sender, let's try to import here our noise. Let's see if this works. Mm-mm-mm-mm. Let's see if I just use it there. Can we build still? We should. I want to be able to go to definition. I want to see what the root file is going to look like. Okay, so this is still building. Can we go to definition? Oh, come on, ZLS. Mm, I'm gonna rebuild latest ZLS because I'm using ZLS with an unstable version of Zig. So every time when you have the latest version of Zig, ZLS didn't have time to catch up. So sometimes it goes out of sync, and then your ability to go to definition kind of degrades. Okay, let's see if we will be able to go to definition at some point inside our noise. But in any case, so we know what's in there. Oh, you know what's messing up? What's messing this up? Now that I think about it, this guy wants to be exposed to our noise export. Our noise export. If not def, our noise export. If win32 tackle spec. Otherwise defined to nothing. New C. I was wondering if this guy was meant to be subject to this to the other definitions, but no, this guy is fine on its own. Okay, so still cannot go to definition. I'm so curious to see what's going to be in there. Okay, so here's the problem. To make this work, we kind of need to do some restructuring work in the way our stuff is implemented, because right now we're okay. Let's do the crappy integration first. So the problem is that right now, um, the microphone callback is doing the Opus compression, which was fine before, but now it's increasingly becoming a bad idea. Let's see if I can find it. It's below color. Capture push. There we go. So here we're doing the Opus stuff. And the idea is that we would have to do basically our noise stuff here as well. So um, let's start by printing. Let's start by doing this log.debug. And actually that means that we need to import our noise here as well. Our noise dot get frame size. Okay, let's see if this builds. I wonder if I got it right, if I got the header files right. That is the part that I just don't have experience with. Okay, never mind. I think we did. Otherwise, we could have gotten a complaint. Test. Okay, so our noise does 480 frames at a time. What a coincidence. We just so happen that we do twice that at a time. So we would just need to call it twice to get this done. Um, what a fortuitous coincidence. So here's what we can do. So by the way, okay, we're failing to do the go to definition, but man, is everything working beautifully. Our noise pulls in the implementation, has header file definitions in its main in its root file. If you just want the header definitions, you can have them as a separate module called headers. That is, this is holy shit. This is so good. I need to make my Opus package. I need to polish it up to this standard. My Opus package is not this good. This is so far the best package that I've ever made, I think. So let's turn this into an assert. Also, maybe not an assert that we run every frame. So let's do this. Let's do this when we initialize the encoder, the Opus encoder. So we have this const our noise import our noise. When we create an encoder, we do this assert. I mean, no. Why are we doing this? Also, our noise is not Opus, so okay. You know what? You guys come with me. We're not touching this. We're making a new file. Oh, I failed to copy. Okay, const our noise equals import our noise. Pub const denoiser is an opaque. Pub function create. Return add a noise. You know what? I think that while we're in here, let's just call this R so that we have to type less. R and noise create, I guess. I'm gonna look at how this looks like in a moment. But so let's answer that are the noise get frame size um equals 480. Hmm. Anyway, okay, we create it. Then our noise create once a model. So we pass null. We use the built-in model. Our noise destroy. Process frame. Um, let's make it a constant here. Frame size equals 480. Make it a constant so that it's clear where we're using this. So process frame is gonna be returns float. Takes a denoise state. Okay. Takes in a float out, which for us is going to be a pointer to an array of 480 F32s, and in, which is going to be a pointer const to 480 F32. I'm unclear what the return value is. We're going to discover though that in a moment, probably. I'm guessing it returns some estimate of the noise. What is it? No, bro, you cannot return a float value and not even tell me what the fuck is supposed to be. Dude, you have to tell me this stuff. Come on. It's the main core function for using this library. You have to document the return value. God damn it. Oh no. What does it return? If not training, compute RRN. If one return VAD prob. What's VAD prob? What's VAD in this context? VAD. Let's grab for VAD in the code base, I guess. VAD output, VAD dance, VAD loss. Viterbi VAD. Voice activity detection. In the context of voice processing, what might the acronym VAD mean? For example, I can see a variable called Viterbi VAD. VAD dense and VAD prob. Voice activity detection seems a good guess. Okay. The probability that a given frame contains speech. Okay. I don't know what we do with that. I really don't know what we do with that, but fine. Okay, so continuing our crappy integration, that means that we run this here. The crappy integration basically is this. We make one of these guys in audio. So when we create audio, we make one. Also in here, we want to assert the frame size and also assert that frame size. Whatever. I think this is fine. Oh, although we want to use it here. Okay. Then we want to remove all the imports to our noise that was sprinkling around. So this one is gone. The one in network is also gone because we don't depend on the dependency anymore. Now in audio, as I was saying, we're continuing the crappy integration where we have a denoiser. In init, we need to make one. Okay, we make a denoiser, and then in here, before we compute the power and we think about this stuff, we just pre-process this guy. So um, it's gonna be audio.denoiser, capture denoiser dot process frame. Now here's an interesting question: can output and input be the same? Here's another delicious question: can these guys alias? Oh wait, actually, it doesn't matter. No, it does matter because we have to read from the ring buffer. Fuck. Huh. Is it a problem if they alias? If only the docs told us this stuff. Either way. They don't have any no alias um, definition on them. So I guess why not? Yeah, look, it makes its own frame size buffers internally. So YOLO. So I think there is no shame in that. So output is gonna be um, PCM slice from 0 to Awebo, our noise, frame size, dot .ptr. Actually, no, that's it. And then the second one is gonna be Awebo frame size, dot dot. And I think the math should work itself out correctly. I don't know what that number is, so we don't care. Although, you know what? Um, technically, if you are doing okay, this is a shitty integration, but in the way we want to do it, the threshold, the capture threshold, and the capture denoiser are mutually exclusive. We only do one at a time. So that means that essentially this number here, maybe we can use as a yeah, no, you know what? I actually have no fucking idea. Never mind. Let's see if this works. Oh yeah, can create fail? Of course create can fail. How do you check for failures? I guess you test for null. Uh Man, why can't I go to definition? I wish I could. So close yet so far. Accepted type of will be denoiser found optional. Right. Or else return error dot out of memory. There you go. Problem is const the equals return at pointer cast b. Frankly, this wrapper is not all that convenient, but it is convenient for this. Okay, I think we're in business. I think we are in business. and we can test this. This microphone is just not noisy at all. So okay, let me just try it just to see if it poops itself immediately and crashes. It doesn't. Okay, so it kind of works. I guess we can pause the music and see what our noise does to our voice. So I'm going to enable audio also on YouTube. Bump it up. Oh, test. Ah. So here's what I think it's happening. Oh, I forgot to do half of the frames, I think. Oh no, I completely fucked it up. Wait a second. Capture push. I fucked it up. I'm oh my god, what am I doing? So we call it twice with this and twice with this. Because our frame is twice the size, so we do the first half and then the second half. Obviously. Also, there's another question of whether this is fast enough. If we hear artifacts, it might be that it's not fast enough. Let's see. Test. No, it's fine. Okay. You're hearing me denoised. All good. Now, I'm going to switch to the crappy camera microphone, which is really crappy. There we go. This one is really crappy. Is there a way to hear this back? Test. No, I can change the volume, but I cannot play feedback when volume is changed. Oh, but this is not for test my input. Okay, so this thing doesn't allow me to test my input. It's fine. Test. Hmm. It's not really all that clean. Hmm. Hmm. Test. Let me try. Let me see if I can find on my phone like a vacuum cleaner noise. Okay. Vacuum cleaner sound. Let's go. Extended 10-hour version. Sure. What the heck? Test. It's not really going too well, is it? Test. Nah. It's definitely going through. Okay, so what are we doing wrong? It's not this. Because we are with the 5PCM, we copy our data init and then we denoise it. So no, we are processing this with the denoiser, but it's not really doing much. So the fact that everything compiles, the fact that we are getting like that function that was telling us how big a frame is, it means that this stuff all works fine, but somehow like the model is not kicking in or something. Why? We are also processing frames in the right order, I believe. So it's not like I'm feeding data backwards to the model or something. So why is this not doing what it should? You know what we can do though? We can we can test the same. We can try the same thing that we were trying before with that. We can dynamic link. We can dynamic link against this library. So this is going to be funny. Okay, let's see if we can do this. So I'm going to go into my build script, and instead of in GUI, instead of using the module array noise, I'm going to use headers, which should give me access to the headers. So that means that if I build now again, I should end up with undefined symbols. You should fail at the linking stage and complain about missing symbols. There we go. There we go. Perfect. So, like mono, no, it's already mono. What we're feeding to the model is already mono. Okay. So this works. Or rather, we're failing successfully. Now, here's what I'm going to do. I'm going to completely remove my stuff out of the equation by cloning the original project. So git clone this in Zig noise. Run autogen. That server is so slow at downloading these models. Holy shit. Okay. Okay. Then we configure. There's really nothing that I care about here. The default configuration, I think it's fine. And then we make. Oh no, you know what? We want the prefix. Wait, we want the configure prefix. We want it to be slash user slash Christoph. Okay, make. Wait a second. Make clean. Make. I did make clean because I interrupted it halfway through earlier. I think it did not finish. There we go. Make install. And now I have this stuff in out. So now I can go in brew uninstall noise in case that I do have it from brew. Okay, perfect. Thank you, brew. So then oh, I deleted that line. That line was useful though. GUI.root module dot link system library. Let me think about it for a second. Link system library. Name. Noise. Options. Prefer link mode. Dynamic. And then we need a path. GUI root module dot add include path. CWD relative. Zip error noise slash out. I don't remember if this works or if I might need to do one extra round of building. Yeah. Because wait, this is not include path. Add library path. There we go. Will this help? Still won't. Okay, what if we do this? It's not really CWD relative. It's like CWD relative, but also absolute at the same time. Would that help? I guess it's out/lib. Okay, so now we're using the official build. Test. Motherfucker, this one is working. No. I don't know. Also, let me change the threshold. Yeah, threshold to 0. Yeah, you can always hear it there. It interrupts at some point, but that's a different mechanism. That's obvious that interrupts it. Huh. I don't know. I don't know. That's the official one. Maybe some other noise. Maybe some less aggressive noise. Maybe that's a dead vacuum noise. I don't know. No? Always there. Huh. I don't know. I don't know. So this is not it. Our build is fine. So is the README right in saying that it should be PCM 16 instead of float 32? Like, who should I trust? The README says that it's 16-bit row PCM. Also, are we depending on main branch? Here's another question. Exit this. Exit this. Here. Main branch. That is a different commit? Question mark? It is not, because otherwise we would have rebuilt here. Test.
Test.
Test, 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 test.
Test.
Yep.
Yep.
The file is for the example tool. What are you talking about? So file. Open. I mean, this is still doing short. This is doing short. Let's look at the implementation. It might be that it's the header file that lies. Oh, you know what? Maybe there are some things here that tell us about this. Like for example, if search for float. Okay, there's no mention of that. I'm flabbergasted. Why would the include file say float and then it doesn't take float? Like nothing makes sense. No, it cannot be that, right? Process frame is float in, float out. Yeah, this is floats. Like this is floats. The thing is just not updated. It has to be floats. Max 16. What the fuck is max 16? Yeah, it's all float. Okay, so this truly is float. I believe it. I guess on branch 0.1, probably this was not float. Would not be surprised. This is still float. It's for the binary tool. Okay. Our noise demo. Yeah, but here's the thing. Okay. Yeah, but look at this. Where do you see it transform um, from one type to the other? Because where do you see in this tool that they load in one format and they turn it into float? XY equals temp I in here. Oh. Oh, you're right. Wait, is that how you do it? I expected the process to be slightly more involved. What? I mean, but what? No. Wait a second. That's not how this works. You can't just take a you cannot just take a signed I16 and turn it into a float like this. Wait, no, actually, that might explain it. No, but here's the point. Here's the point. My floats are all values that go from 0 to 1. Maybe this is why it doesn't work. Because we're using floats that go from 0 to 1. Hey, Giacomo, thank you for the raid. Thank you very much. Hello, everybody. Welcome. So for the people who have just joined, we have just packaged RN Noise, the noise removal library from Ziv, with Zig, so that we can build it more easily. But I tried it out and it doesn't work. Or rather, like it compiles everything works, but I don't get noise removal. So I'm trying to understand why that is happening. And I think that the problem is that I think that it accepts float now, but they expect that float, I think, to be not clamped between 0 and 1. Or maybe -1 and 1. I actually don't even remember normally what range float is in. I think it's between -1 and 1. They expect float to be the 16-bit PCM int thing. I am. Why I don't know what this sentence even means. Yeah, thank you. It's not too bad. I just need to learn how people do things with audio. I mean, with Opus, I'm good. I just need to learn how our noise expects things. So um let's ask the LLM. Um if a library that reads int 16 row PCM samples turns them to float by assigning each int 16 sample to a float variable. What is the expected range of float values? Because I think the fact that our things are go from 0 to 1 is the problem. Wanna bet you that if we modify our number, if we multiply our numbers by this value, we're gonna get the good stuff. Let's see. So we go in audio. Before this, um, I guess we kind of would like a vectorized multiply, but well, right now for simplicity, let's do 4 PCM. So multiply equals, what was the magic number? 32768. And then after that, we divide. Now I'm curious. I think this is it. Because the way it does conversion, it's too suspicious. Test,
Test,
test.
test.
Okay.
Okay.
Yeah.
Yeah.
Yeah, it's
Yeah, it's
working.
working.
I can
I
tell that
can
it's
tell that it's
working.
working.
Vacuum cleaner
Vacuum cleaner
sound.
sound.
Full
Full
blast.
blast.
Yep.
Yep.
Can you guys
Can you
hear
guys
it at
hear
all
it at
when I
all when I
talk?
talk?
Can you
Can you
hear
hear
the
the
super
super
noisy
noisy
vacuum
vacuum
cleaner?
cleaner?
Yeah, it's
Yeah,
like a
it's like a
fucking
fucking
airplane.
airplane.
That thing was
That thing
like a
was
fucking
like a fucking
airplane. It
airplane.
was
It
super
was
noisy
super
like it
noisy
was
like it was
before.
before.
Here's your
Here's your
answer.
answer.
Here's your answer. This model wants your flow to be clamped in that range. If only those fucking, if only the author were to document this, man, please. Like, they just need to know to explain things. Why do I need to discover that that's the expected range for your float values by looking at the suspicious float assignment? By the way, thank you, Der Teufel. You pointing out that that was the line, that really helped me. But you see, the point is that you like floats normally everywhere else in this whole ecosystem, they've always been clamped between 0 and 1. And now we have this like arbitrary range. I mean, it's not fully arbitrary. That is, I guess, a range that that it is convenient, maybe, to keep your domain into for easy interoperability with int16 PCM. Yeah, but it's silly. There's no point to do that with floats. Like if you're just doing native float, you just stay in 0 and 1. Why would you move? So there we go. Here's the answer. Gotta do the rando multiply and divide to make it work. Ta-da! So we solved this mystery as well. So turns out that this library didn't have much mystery when it came to packaging. Packaging was fairly straightforward, but it did have mysteries when it came to using it. I'm gonna put this in my bindings here. Actually, no, you know what? I'm gonna put this in the README. Okay. Deny to deploy key. Uh, God damn it! Why is it doing it like this? Okay, and now we go in older code base, and we're gonna set main as the default branch. Okay, perfect. Why do? Oh, okay, I was saying, well, where's my syntax highlighting? Okay, it seems that this is a good attempt. Okay, so we have our noise. Now integration is the integration that I have right now is horrible. So we are gonna need to make a proper integration for all of this stuff. So the way it works right now is that uh, you can actually see it in audio. You can see that this is the audio callback, and the audio callback has its own happy little ring buffer that it writes to. And this ring buffer is not atomic at all because it's private. It's its own ring buffer. And then what we're doing here is that we write to the ring buffer, and then if we have enough samples, we read from the ring buffer. Here we say basically we copy over what we had from here. Then we say, okay, do we have enough samples to make an Opus packet? If we don't, then we do nothing. If we do, then we copy over what's in the ring buffer here. And then now we multiply, divide, and we multiply, we divide, and then we multiply, we denoise, and then we multiply, we divide, and then we compute power, and we compress with Opus. Now, it's a lot of stuff that is happening in this audio callback, and it doesn't have to be this way. So, what I am thinking is that I think it should be the network that does at least some of this stuff. So basically, right now, this callback talks to the network via a Opus packet ring buffer. We do have a ring buffer for Opus packets with atomics and whatnot, but we don't have one for samples. Um, I don't know. We could keep it this way. We're just doing a kind of ton of work in the audio thread, but as long as it's not a problem, we could keep it this way. One thing for sure though is that, you know what, maybe I'll leave it like this for a while longer. Let's first encounter problems with this setup before we change it. But there is one thing for sure that we want to do. It's either noise canceling or activation threshold. It's not both. And right now we're doing both. So let's fix this. Basically, this is now going to be a more mundane thing where we need to change the users how user settings look like, and we need to give the user an option to do one or the other, and we need to track this in audio and decide what to do. So we have the noiser, we have a threshold, and then we have capture noise get noise gate. Noise gate is going to be a noise gate. Here we do pub const noise gate is going to be an enum. It's going to be it's going to be denoiser or activation or threshold, I guess. And I don't know, we default to the denoiser, I guess. Okay. Capture noise gate. Okay, then let's go into the user settings and we say input volume, and then here's activation threshold. Oh, now this is going to be different. Now there's going to be a drop down menu. So it's time for a drop down menu challenge. So it's going to be var noise gate box. I don't know. DM. DVUI dot drop down enum. Holy shit. Oh, I love this. T type choice, drop down choice of T. Type is gonna be core audio noise gate. Choice is gonna be I don't know yet. I don't know how you set that value there. Let's see. Show add tag name of choice and click to display all tags in that enum in a floating menu. Returns true if any enum value was selected, even the already chosen one. See drop down widget for more advanced usage. Only valid between window begin and window end. That is fine. What's the drop down choice of T? Will display placeholder when text null. Drop down init option. Placeholder null selectable. So null selectable is false. Okay, we're almost there. T type and then choice is an instance of this. Choice and choice nullable. Okay, I think I understand. So we're going to do var noise gate choice of type dvui dot drop down enum. No. Oh man, that's not the type. Oh shit, I killed flow. Uh, what did we lose? Yeah, we lost everything. God damn it. Noise gate choice. Drop down choice of for audio dot noise gate. Can we give it a default value? No. That makes sense though. This is gonna be dot choice equals ampersand core dot audio dot capture noise gate. There we go. Oh, you know what? Actually, these can be set in line. Yeah. Core audio noise noise gate. Okay, there we go. And then this guy, oh, this returns bool. So this is more like if. Mm-mm-mm-mm. Actually don't care. Yeah, we don't really care. Okay, what matters though is that after this, then we switch core.audio.capture noise gate. And depending on what's selected, we show different options. So for example, we only show activation threshold if this is enabled. Do we keep the preview around? No, I think the preview makes sense only for the thing itself. So this can go in here. And for denoiser, there is no settings, essentially. Okay. Then, oh, here's though the problem. We want that option to be atomic so that the audio card can read it. We already made the other thing atomic. This one needs to be atomic as well. Huh. Yeah, we'll need to complicate this a little bit. A tiny little bit more, just like we complicated this one down here. Okay. But let's see what this looks like. Already have one open, close. Yeah, okay. The noiser threshold. We need to add a label. Mm-mm-mm. Noise gate. Okay. From a like user friendliness perspective, what I'm doing is not like it's not exactly state of the art, state of the art when it comes to like this being good user experience, but you know the mechanics are there. So it's either activation threshold or denoiser, depending on which one you pick. You can either choose the one or the other. I wish there was a nice way that the UI supported to print these enums. Does it support FMT? If okay, if there is FMT support, I'll be ecstatic. No, there isn't. God damn it, David! You were so close to greatness, so close to greatness, because you can do this. Um, man, so close to greatness. Because you can take an enum and give it a format method so that you can have a cutesy name for it. So in audio, we can go here and we can say pub function format. Oh, but format wants a writer. But no, it doesn't matter because he could do that. No, it just works. So format should be ng noise gate io.writer try w.print. Actually, it's more like switch ng. What am I doing? Actually, this can be write all. So write all is write all still a thing? It is. Okay, write all. Like denoiser, activation threshold advanced. Why can't we have both? Why would you want to have both? By the Teufel. Maybe here we can add a label with some explanation. Let's just leave it at that. See what's going to look like. It really squishes the other thing. It squishes the other thing a lot. Mm-mm-mm. Yeah. I wish these text could like automatically fade. I think it's my fault because I should not be using label. I should be using something fancier than a label. You know what? Maybe it's time that we actually learn how to do this. dvui.text entry text layout. I think we want a text layout. Break lines true, cache layout false. Can do true. Focus kerning selection. Show touch draggables touch edit just focus. Wait, and then they give me a text layout. What do you put inside? Labels? Oh, I call add text on it. Okay. Does it want options? Okay. Okay, let's see what this looks like. Yeah, that's more like it. Although it still pushes it still does push stuff out. Test,
Test,
test.
test.
It still pushes stuff out. But I guess it's fine. We can give it a max size maybe. So just like in the threshold, somehow we figure out the max size. Preview data content rect scale R. Hmm. Okay, let's see what this does. It does keep squishing the other poor guy. Break lines through kerning equals uh we know the kerning setting. Okay. I don't know. Ah, I think this is fine. Okay, so we have the two settings. We need to make them atomic so that we can load them appropriately, I guess. I kind of wish I could do all this whole thing at once. So here's maybe how we can do it. We can assert, and I was about to say that we can assert that threshold should never be zero, and we use zero for our noise. The problem is we don't want to do that because we want to remember the activation threshold if the user switches. So we don't want to kill that value. So no, we want to make this atomic and period. There we go. Noise gate, the noiser. Right. This enum needs to be given a size. Okay. Then we need to go in AV and fix usage here. Var uh, noise gate choice equals for audio dot noise gate dot load unordered. Noise gate choice. Unordered, and then here we do noise gate choice. So far so good. Then in audio capture push, it's kind of like this. If I mean, yeah, but I think we are going to need to save this as a variable. First, we do this silly goose dance. Actually, this part is unconditional. Okay. So how does it work? I think that basically, um, basically we what we want to do is just not do this. We do want to compute power. Oh, we are saying if this is silence or not. I think we want to do this anyway. Ah, Opus DTX is making things more complicated for us. Hmm. I think essentially, here's what we're gonna do. I think. And in the case of the noiser, either we want well, maybe we could have, you know what, we could avoid computing the power. Okay, let's do it like this. Silence. Let's set it as a let's set it like this. Threshold is gonna be this. Then power is gonna be this. And then silence is gonna be essentially all of this. Does it even matter if we do silence or not? Yeah, because we want to report silence. Okay, I think we're almost good. So if it's threshold, grab the threshold, compute the power, do the silence stuff. If it's silence, mem set to 0, break with silence. If it's the noiser, well then okay, I'm gonna copy this here. And we're gonna say what? So how do we conclude whether this is silence or not? Are you a game developer? Not really. I think that in this case, I think actually in this case, the silence competition might not even be interesting. Why do we do this? We look at silence in network. Let's see what we do with silence in network. Oh, it's for deciding whether we are speaking or not. It's for deciding whether we are speaking or not. Well, let's do it like so. We never say that this is false. Silence is silence, and write.data.len greater than 2. But we kind of already know this, right? Actually, we already do this. What if length is lower than 3? Yeah, we already do the early return, so we don't even care. Okay, never mind. This doesn't help. This does not help. Um, this does not help. Oh, wait a second. Also, I just realized. I think I saw in Opus a tool that I guess it's meant to be used with our noise. But I never looked into much. I never really cared because it wasn't necessary. But look at this guy. Where is it? Yeah, look at this. PCM soft clip. Let's see. Apply soft clipping to bring a float signal within the -1 range. If the signal is already in that range, nothing is done. If there are values outside, then the signal is clipped as smoothly as possible to both fit in the range and avoid creating excessive distortion in the process. Maybe this is for helping us. I was saying, wait, why would my float signal be outside of this range? Well, I know why. Because we maybe do the multiplication. Okay, I need to figure out how to know if it's silenced or not. We can look at the return value from these guys. So, man, we can look at the return values from these guys and say that if it's lower, if the confidence is above 50%, then it's not silence. Okay, that would do it. Let's see if it works. Mm-mm-mm-mm. So,
So,
echo.
echo.
It still
It still
lights
lights
up,
up,
unfortunately.
unfortunately.
This is a
This is a
bug.
bug.
That being
That being
said,
said,
let's
let's
switch.
switch.
Threshold.
Threshold.
Super low
Super low
threshold.
threshold.
Let's
Let's
do the
do the
vacuum
vacuum
cleaner
cleaner
stuff.
stuff.
Sorry,
Sorry,
it's
it's
my
my
main
main
microphone
microphone
picking it
picking
up.
it up.
Not
Not
bad.
bad.
Also,
Also,
you can
you
hear
can
my
hear my
voice.
voice.
Let me
Let
mute
me
my
mute my
main
main
microphone.
microphone. Okay, only through the application. Vacuum cleaner drawing. Uh, Not bad. Not bad. Uh, Not the greatest. No, no, no. It is super intelligible. I didn't hear crackling though. I do wonder what the crackling is. Maybe it's my fault. Maybe I should apply the soft clipping. Let's do it.
So what if instead of dividing these numbers by myself, I use the soft clipping that they give us? Okay, let's do one more test. So the test is we hear with the denoiser, we hear crackling. So test. Um, Hello? Oh shit. Why? What is the problem now? Bro, please. For some reason, it failed to initialize the microphone. Please,
Please,
Mac.
Mac.
Okay.
Okay.
So,
So mute my main microphone. Only shitty microphone. Uh, uh,
okay, never mind. It's just clipping because I'm too noisy. So it's just my fault. I have the volume set to I, and the microphone clips. And it was probably clipping with the super loud vacuum noise. So, okay, I think this is as good as it gets. So with this, we have denoising or threshold enabled, and you can pick your poison. I find this delightful. Are you doing this mini server with capture auto capture only for your phone? No, this is a crappy Logitech webcam that I have that also has a microphone, which is connected to my Mac Mini, and that's the audio device that I'm using for these tests. Hello, that's the camera. No, my phone was playing vacuum noises. I was. Yeah, my phone was just making those noises. New RN noise is really good once you know how to use it. Okay. So this is good. Now, how have I somehow fucked up um notifications? How? So I was trying to understand why do we see this light up again? Ooh.
ooh.
Okay.
Okay.
It's
It's
very
very
sensitive.
sensitive.
Okay, I don't know this, but the light up, the like regular light up, that's not a bug. So here's how we diagnose this. I'm on branch main, I am. So in network, let's not put out local feedback. So let's only do remote feedback. Is it remote feedback that we're getting? Oh, come on, man. Yeah, new function parameter. Yeah. Okay.
Okay.
Okay. It is the local feedback that is freaking out. Why? Why is the local feedback freaking out? How the capture silence count greater than 10? So the threshold one should be obvious. Maybe it's this one that is bad. But so the capture threshold one should be fine. Yeah.
Yeah.
Okay. It's this guy. Okay. What fucking numbers are we getting from the model? Please. This thing is again returning float numbers that are not normalized between 0 and 1. I hate this. God damn it. Okay, show me what you're doing. Please don't tell me it's giving me a number between 1 and 0 and 100. Actually, I don't know what I would hate more. Like 0 and like percentage expressed in over 100, or like I don't even know. Uh
Uh,
uh
uh,
uh
uh,
banana.
banana.
Oh, well, that's one problem for sure. That explains it. But I think we can even do better. We can bring up the. It seems very well fine tuned, so we can bring these numbers up. Okay, I found my bug. I think actually it's also not or. It has to be and. It's silence if both. Oh, here's another thing though. Oh, this is interesting. Test.
Test.
Uh,
Uh,
okay.
okay.
There's another thing. This is like much more um sensitive than this one, because this one you only say that it's silence if it's been silenced for 200 milliseconds. This one is going to say that it's silence for 10 milliseconds. That being said, we do keep the light on for a given duration, so it should not be a problem, I think. It's just that, but the semantics are a little bit different. We could do the same thing here, but whatever. Hello, how do I read std in chunks of a certain size? If the remaining data is less than the certain size, we just read it. Can seem to get this right using take functions. You want to read SCD in chunks of a certain size. And then if the remaining data is less than a certain size, you just read it. Yeah, no, you don't want take. Let me take a look. You want so limited fixed string discard blah blah blah. You want this one would do it. Stream exact would work. It requires you to have a writer, but stream exact is kind of what you want. Let me see if the take functions help. Actually, why does take not work for you? Take? Oh no, I see maybe what the problem is. The problem is that you have data. Wait. You have data in the standard input. I think your problem is so you have to tell me more about what your setup is, because if your standard input doesn't close, then what you're describing doesn't make sense. So what is your standard input? Is it you typing in the terminal? Are you piping a file in? Are you piping from another process? Because the question is whether the standard input will close at the end of the input or if it will stay open. Well, I'm waiting for you to reply, but to give you a general answer, if your input, if your standard input closes, like if you pipe a file to your process, let's see, that's fine, it's fine, but then when I echo a small string, then I just get stream closed. Thanks for helping. Okay. Are you saying that you get stream closed without seeing the data? Oh no, that makes sense because you call take because you call take according to big followed by toss. Mm-hmm. I think that essentially, let me see. Yeah, because probably pick is what returns the stream closed. So the question is how you basically when this fails, you have to call another function um to see what is it that remains. Let's see. You can call read slice endian. Fill buffer with the next buffer line bytes from the stream, advance in the seek position. Um, take sentinel, pick the limiter, take the limiter. Stream the limiter. Stream the limiter ending. Fill. Fill more, pick byte. Okay, so here's what I think it happens. Trying to access the buffer segfaults. Trying to access the buffer segfaults. That seems suspicious. Trying to access the buffer should not cause that. So here's my recommendation. Oh no, don't copy paste code in here. Go to Zigbee. Go to zigbee.io and paste the code there. In any case, I think that the primitive that you're looking for is stream. I think this is what you're looking for. I think that you want stream into a writer, and you want to set the writer to have a buffer of the size that you want. And then you keep calling stream into the writer. That is, in my opinion, what you should do. That being said, you need to be prepared, and probably it's not a bad idea. You probably should. That you for the case that you might get small reads, even if you're not at the end. Okay, write a buffer. Yep. While SD intake buff size chunk, extractor convert chunk decoder writer. Okay, that's one way of doing it. But essentially, when you get to the end, you kind of want what you're missing is the fact that you're not able to take that number of values, and you need to have basically a way of saying, okay, give me anything that remains. Uh, so the stream thing that I suggested is an option, but it doesn't seem to match too well with your use case here. So never mind the stream. Um, the stream remaining, discard remaining, unlock remaining. I think at that point you just want to have a there's read back. So okay, one way of doing it, since let me think about it for a second. No, you can do this with take. So here's your problem. You can do this with take. The problem is that where's the thing? The problem is that when it fails the last time, you have to use a different function to say give me whatever remains. I tried accessing the reader buffer after get stream is closed, but that's like false, and I want to take natural time though. No, don't worry. I find it weird that that seg false. So let me try. Let me try. Okay, we don't have a key DY, so we don't do this. In our case, I guess we just print the chunk back. Okay, so let's let's do this. Zig run stream.zig. I think we might need to build exe and then run it afterwards to avoid weirdness. So build exe. Oh, also you're doing, oh shit, you're doing FS files, Dean. Oh, that is interesting. Um, you might be encountering issues that have to do with your, with the fact that you're using 0.15. It's IO, yeah. Um, okay. Also, what is our thing? Oh, Jesus, buff size is a lot. Let's say that our buff size is now 5 characters. Probably want something like that. Arsta, stream closed. Okay. So we are experiencing the problem. Okay. So what can we do here? If stream is closed, can we do std in dot append remaining? Append remaining, unlock remaining, unlock remaining. Init.gpa limit unlimited. Okay, let's see how this works. So, and essentially want to do it here. Let's see how it goes. It doesn't do this. Is the arrow read failed? No, I think it's oh no, you're right. This is outside. This is not refailed. We're getting stream closed. Never mind. That wasn't me. Okay, let's rebuild. Move the logic where it should be. Rebuild. Boom. Memory address leaked, but it worked. So, and the fact that the memory address has leaked, it's fair. Here we want to do the fur. Init GPA dot free rest. There you go. Okay, so if you are getting um if you're getting error, I find it weird that you're getting that you're getting a seg fault if you try to access the buffer after stream closed. Um, it makes me think that the problem is something else. That being said, there has been a giant overhaul of all this stuff, between different versions of Zig. So who knows? Maybe you have maybe 0.15 was left with a bug related to that. That being said, I do find it really uh, not very probable. So, well, alloc remaining is an option. There's also stream remaining to an existing reader. There's also, I think another one is this. Another option is to do peak. Let's see. Returns the next n bytes from the stream from the buffer as necessary. Maybe not peak. Fill buffer. Peak greedy. Peak array. Peak sentinel. I'm actually surprised that there isn't something that just tells you what's in their buffer directly. Because if you got end of stream, you know that whatever remains is in the buffer. Why not just add std.buffered? Which seg faults? Oh. That does make sense, doesn't it? These seg faults? Okay. Let's try. Equals try no std.buffered. Okay, let's see. Yeah. I don't see why this should keep in mind that this, like for this to work, by the way, thank you. Buffered is what I was looking for. I was having trouble finding it. But yeah, this is what you want. Buffered is exactly what you want. And like if this works, this also works. Like alloc remaining takes data from your buffer. So if you seg fault when you get here, the only thing that I can think of is that you have, it means that it's because you have freed your reader buffer before somehow. So maybe not in this simplified repro that you shared. I don't know if your original code is more complicated, but this should not say fault. That being said, maybe the seg fault that you're experiencing is a bug that was introduced in 0.15 with the reader writer interface change that was fixed afterwards. Here's another question for you. Which 0.15 are you using? Are you using 0.15.0, 0.15.1, or 0.15.2? If you're not using 0.15.2, I highly recommend you upgrade to 0.15.2. Okay, you're already there. Yeah. So I would say it's either on you or you are experiencing a Zig bug and you should upgrade version of Zig. One of the two. Okay. So you were already doing it, right? I mean, in terms of using buffered. Yeah, no problem. No worries. Yeah, what are we doing here? I think I am at a point where I can commit this. Like we fix this. We just need to make a comment. This status. Oh no, almost. Wait. I pushed rn noise. I made it the default branch. Let me double check that I did this correctly. So rn noise. Not this rn noise. My rn noise. Oh my eyes. Underscore base rn noise. There we go. This is my project now. I should probably point that out to the other guys. To Jay Lucaso and Marler. but they touched this like the last time they touched this, it was like 2 years ago. So uh, I would expect they don't mind too much, especially since I did such a good job. Man, I'm so happy and proud of this package. Actually, you know what? I think I wanna push a README change uh, to create static and dynamic libraries. Dynamic libraries. See Zig build -h for all custom options. Usage from Zig. If you're using this library from Zig, import the RN noise module, which will contain the full implementation, i.e., full implementation. So static linking. Well, I mean, we contain the full implementation and translated C header files, e.g., um, for example, that you can header files which you can use like so. If you want to make use of dynamic linking, then uh, add the dynamic library as well, actually, what do you do then? Well, then you can import the headers module, which will contain the translated C header files, but none of the implementation. Okay. User, you know, this library expects flow samples to be in the blah 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 range. Force with lease. Okay. So with this, um, we're done. And now in Awebo, we can go into our build script, and actually we can go into our build script. We can remove this test because now we figured it out, and then we go to our zone file, remove our noise, add it, test that it works. Perfect. Then we need to make sure that it builds also for the platforms. So we need to run CI. But I think I messed something up CI wise. I know for sure. I think in the build script, do we do this correctly also for the other guy? Yeah. Okay. Okay. No, never mind. We're good. So Zig build CI. Now we get to build our noise for a bunch of different targets. Oh no. Well, and net SSE for one is being compiled without SSE for one enabled. And net AVX2C is being compiled without AVX2 enabled. Okay. Are we looking at our noise? Because I can't tell anymore which project we're looking at. Yeah, we're looking at our noise. Only when the buffer size is 32 times 124 and with 5 it works. What? I'm gonna try this out then. I mean, it does mean that it's doing an out of bounds access, right? Like the segfault has to be an out of bounds access, and 32 times 124, it's probably 32 is a multiple of 4, so this is a multiple of page size. So you're probably segfaulting because you're getting into a unmapped page. That's my guess. Okay, give me a second, and I'm gonna try it. Okay, let me just let me just solve this. Why is it saying that we're doing this stuff in such a wrong way? Actually, maybe I know. You know that I think there's an issue about this that Johnny Marler made. NNet AVX2C is being compiled without AVX2 enabled. Okay, who's adding this? Who is adding this? Let's is this our noise? Yes. So no. Source is AVX2. Oh, it's because of the x86 RTCD. Wait, isn't this supposed to be correct? I remember that the build script. Yeah. So I changed this. I made it so that if you're targeting x86 RTCD, you compile AVX2 stuff, regardless whether you know statically that that is the case. Okay, maybe I misunderstood something in here. Let's take a look at the original project. I might have misunderstood their build stuff. In their make file, they have a line where they say, if enable this, then RN noise sources, you add this, and you add this. The yeah. Okay, so let me look at, there's a PR coincidentally from Johnny Marler about this. Let's see what he says. When emulating AVX for non-AVX targets, the M265I type is being type deft. Okay, so he's talking about something more specific. Um, okay, so that's not our problem right now. Am I really misunderstanding this build script so hard? I think we need to take a look at the configure AC stuff as well at this point. Current version build. AC, substitute this, substitute this. Arg enable. Oh, I think I understand what's going on. Uh, what is going on is that, okay, I think I understand. The problem is we don't know if the CPU has AVX2 or not, but we would like to do runtime detection to decide if we can use that implementation or not. The problem is we are compiling and the compiler has this feature disabled. So that means that if we have RTCD, I think we need to turn them on in the target. Either we can do that, or it's a feature that the Z compiler doesn't support, or slash build system doesn't support as it should. So target.result.cpu.features dot add feature, but it's like this. Feature set with the bits specified. Yeah, and it calls x.add feature. Oh. Add feature set. Add feature. I guess that we can do std. Okay, then I'm this is the first time that I'm using this API. Target x86 dot feature all features CPU dot no dot feature. Well, that's a type, right? Oh, maybe this is it. Dot avx2. Is this a thing? Oh, don't tell me that these features are frozen. So that means that this is var expected u9. Yeah, I don't think I'm doing it right. Add feature, but not its dependencies. Properly dependencies and bytes count is empty. So how do you add a feature and its dependencies then? Hmm. How do you add a feature correctly? Standard target options. Maybe here we can do stuff. Whitelist default target. No. Detect CPU and features. Target CPU baseline. Detect CPU and features. Explicit. Backup CPU detection. Hint from enum. Okay, so this is how you do it. Add feature, remove feature. Oh man, there's a lot of logic around this. So I think that if you have SSC for one, you also must have SSC. And if you have AVX2, you also must have AVX1, I think. Man, it's really hard to know if what I'm doing makes sense. Does this build? It does. But before we do this, let's do the CI fork our noise. Oh, Jesus. Error. Only SSC and SSC2 are available on your machines. Enable SS3, AVX32 using MR to get better performance. Without AVX2 enabled, this does not seem to be doing anything good. Hmm. How is this not working? I don't know. I don't know how I'm supposed to behave with this stuff. Yeah, I don't know how to do this. Hmm. An issue with the Clang front end? I don't know. Here's what we can do. Here's what we can do. We can try this. We can do target dot result dot CPU equals. Where's the baseline stuff? Oh no, we want this one. What if we do this? Expected CPU found what? CPU model. Arch model. It has a set of features which are overridden with the features field. Yeah, god damn it. So result. Hmm. Baselining gives you a model. Why does this not work then? Hmm, 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 hmm. Has all has any. Oh, you can do has. Oh, there you go. Here's how you do the above in a more reasonable manner. Although you still lose the autocomplete, I guess. So this is how you do the above. I don't know how to swap out the CPU for another one. I don't know how to do any of this stuff. Okay, so here's how we do it. And I don't know, we regress the RTCD. kind of sucks. Man, I wish I could do this. I don't understand why this doesn't work. Maybe we're just not adding enough of those. No, this still complains without SSC 4.1 enabled. Okay. You know what? I don't know. Here's what we do for now. Uh, Set it to false, and I don't know. We'll look into it in the future. Does this fix Awebo? Oh, now RTCD is not an option. There you go. Now we're good. Well, I have an issue for this that I can close. I'm gonna ask Andrew and the others if they know what's up with that. So the reason why I don't want to spend too much time debugging it is because I know that I can just ask what is the like way that you're meant to do this stuff. Um. So yeah, this one was it 83. Or was it 83? Okay. So success. Um, we have our noise. At this point, voice calls are pretty respectable. Pretty respectable. So we're waiting for the other audio backends to work, and yeah, and then at this point it's just polishing stability, doing all the chores that I have been postponing, like stop leaking memory, for example. Figure out how memory should be dealt with overall in the life cycle of the application. Like, yeah, do some stuff. Then we also want to start working on video. That is for sure. But video is going to be another Pandora's box for sure. So before we open that door, let's make sure that what we have up until now is in a polished state. So that means that I'm done implementing new multimedia features for a bit. And instead, I'm now going to work on just the rest of the application lifecycle. Every time I close it, it like leaks. There's a bajillion complaints uh, from the general purpose allocator that we're leaking memory. And yeah, we can't have that forever. So this is going to be the thing that we're going to fix. So let me see this problem with the page stuff and the segfault. The error only happens if the buffer size is larger than the data fed into stdin. Okay, let's test this stuff a little bit. So let's look at string.zig. Well, let's see if we're gonna read also garbage. So rest. Okay. There's a new line. Is that new line real or not? Does Echo put a convenience new line? Or is that us reading garbage? Let's do the page alignment stuff. So we could do this for page alignment, but at this point, obviously, the my normal echo doesn't do anything good anymore. So no, it turns out that the new echo does put a new line there. Okay, so what can we pipe in there that goes over that threshold? Well, this one is probably big enough. Okay, let's not print the garbage anymore. Um, I guess we can print it as X. Using fill more buffered and toss buffered. So I don't see the crash. I think that what you have is a bug in the IO reader implementation. I know that those things were not perfect when the release was cut. I don't remember precisely what the issues were, like one by one, but I have this vague memory that some things were fixed after the fact, and I think that in my case I'm not encountering any error because I don't have this bug anymore in the reader, while you do. And I think that you can test this kind of easily because when you get in here, like instead of doing buffered, print and seek and see if they make sense. So what you want is this essentially end, well, seek and end. And then the next question end is end lower than well is kind of like this. Is it okay? Meaning so you want stdin dot buffer. Actually no, it's stdin dot seek, stdin dot end, and then you want stdin dot seek plus stdin dot end lower than stdin lower or equal stdin dot buffer dot len. Although to be clear, that buffer len that we got through stdin, like this guy, is this guy. Um, so seek is 0, end is this number, and it is okay. Like the only reason why you can get a seg fault when going that far, it's because these numbers are out of whack. And I think that these numbers are out of whack because you have a bug in the interface. So that's my verdict in that on that subject. Either you have corrupted them or they are in a silly state because of a bug in the interface, which I would not exclude might have been there in version 0.15 because the interfaces were like just been made and yeah. Anyway, this is it for me. I think it's time for me to thank you all for hanging out as usual. And yeah. I think I'm going to be lazy and not rate anybody. So thank you all.